Okay. Okay. So let's start with this lecture number 6. So this one will discuss about the relevant feedback and also the query expansion. Um, so let's start this one. Okay. So we will look at the how do we reformulate our query and also how do we expand our query. So in most cases, when we do research, so you are in the third year and also some of you in the fourth year. So when you do your research, the most um, reliable tool is the Google. But if you want to have all the paper, like the journals, so you should use the Google Scholar. So that is used for retrieving all the technical paper related to your topic. Okay. So in most cases, when you do not know the keyword, so you tend to change your query in order to get more familiar topics. Okay. So when you change the query, we call it the process of reformulating your query. Okay, so the objective is to get a different set of answer that suit your what is required for your research. Okay, but in most cases, like a new beginner or a new student, when they try to search for a new document that related to his or her topic, sometimes they cannot determine which one is relevant and which one is not relevant. Okay, that's why it is very important that when you find the document, the first document seems to be more relevant to your query. So I suggest you to read the document first or the link to that document and try to understand the basic concept, and then from there you move on. Okay, the more you read, the more you think that you don't know because you just know by reading that document. Okay, so the first query formulation should be treated as an initial attempt to retrieve relevant information. So you put in your query, and then um, they will give you the retrieve document and also rank them. Okay, so up to you to select which one is relevant to your scope. Okay, so they will display the top and rank document. So it could be 10 or 20 or 5 depending on your query. Okay, and then you will check which one is relevant and which one is not relevant. So by checking or by opening the link, that indicate that you tell the system that this document is relevant to your research or relevant to your search query. Okay, so you indirectly tell which one is relevant. So we are trying to let me get this one. Okay, we are trying to establish this boundary. Okay, so which one is the relevant document and which one is not relevant. Okay, so this is what we call the process of finding relevant document, and then um, once we get the first phase, then we tend to change the query or reformulate the query so that we can have different set of results. So the objective is you do not want to have the same result, but you want to cover or explore a new area which might be relevant to your query. So the process of query modification is commonly referred as relevant feedback because you are providing the information to the system about relevant document. Okay, so when you change the query, it means that you are expanding the query. Okay, so let's suppose we have this. So your initial query is this one. So basically you are looking at all this document here, which is relevant, and you do not want to have all of this. Okay. So your aim is to move to this direction. Okay. So the only way for you to move to that direction is that you need to change the query. Okay. So that it move to the right direction. Okay. You may going to this direction if you key in irrelevant keyword. Okay, this one will move away from your positive document. Okay. So when we assume the top nearest neighbor, so we are looking at, let me erase this one first. Just okay. So when we're looking at the top four nearest, so we are looking at the positive, the positive and negative, which is nearer to the point. Okay, so we assume that these four are the nearest neighbor, but we, when we really check, we only have three positive and one negative. But we assume that these four are all relevant with respect to your query. Okay, so what we want to do is we want to reformulate the query so that we get a better result and we're going to that direction. Okay? So how do you reformulate the query? They may give you a list of suggestions based on history or based on number of hits. So they will suggest to you, or you may on your you may use your own keyword. Okay. So this is when we moving to this direction, meaning that this is the new expanded query because we are going to the right direction. So if we talk about the movement of that position from the initial to the current situation, there are a lot of calculation there. Okay, so how do you know that you're going to the right direction? So you need to measure the distance between the current position to the four nearest neighbor. Okay, so we could use the cosine distance or Euclidean distance in order to compute the distance. Okay, so there are two basic approaches of feedback method. So the first one is called explicit. So explicit means you are providing the feedback direct to the system. Okay, so for example, you may answer a survey or you may inform the person in charge so that these are the relevant document. Okay, so you interact with the system or the survey or the person directly. Okay, and there is another one, what we call it implicit. So this one we are not directly giving the feedback, meaning that we don't know whether our action will be captured in order to uh, indicate that certain document is relevant to that particular keyword. So this is derived by the system based on your movement or based on your feedback, um, or based on your click, or where you see the page, and also the search term. So all this will be captured. So all these activities will be considered when they do user profiling. So they will look at what you click, what page you watch, and then what keyword you key in. Okay, so this is what we call implicit feedback. They indirectly get your input from your um, action or activity. Okay. Okay. Now we look at the framework for feedback method. Before we proceed, do you have any question? So we are looking at the relevant feedback. Okay, so our feedback will be captured indirectly. So this is what we call implicit. Explicit, you will be asked to fill in the survey. So that one is explicit. Okay, so we will focus more on the implicit one. So now we look at the framework for feedback method. Okay, so let's consider a set of documents which are known to be relevant. So we have this the relevant document. Okay, and we have the current query. Okay, so in a relevant feedback framework, the document in DR, which are relevant document, are used to transform the queue into modified query. So meaning that you have the queue here plus the relevant document. So you will transform the query to become modified query. Okay. Okay. However, obtaining information on document relevant to a query require the direct interference of the users. Okay, so we need to ask the user. Okay? And most users are unwilling to provide this information, particularly in the web. Okay, so only if we know this one relevant document which is relevant with respect to the query here, then we can adjust the query so that this modified query will move towards the relevant document. Okay, but the problem is we do not know what is this unless if we use ask the user. Okay, so what we could do is we could look at the document that they click on. Okay, because when they try to search for a certain concept, they will look at they will type in a query, and then they will click on the link that they saw relevant with respect to the query that they have. Okay? Um, Based on the click that they have, we can look at the term belonging to the top document in the result set, meaning that once they click the link, they open the document. So we can extract the term belonging to this document. Okay, so we may capture the title or the most important term that we have here. So this is what over here we can perform topic modeling. So this is one of the research that you can do. Topic modeling in which you try to extract the possible topic for this particular document. Okay. Okay. So this term that belong to this top document can be used in the next search. Okay, so you get that keyword and then it could be expanded to another keyword. Okay, so in both cases, it is expected that the feedback cycle will produce result of higher quality, meaning that whenever you try to um, expand from one keyword to the expanded keyword, it is expected that you get better results or higher quality because of this concept. This one, when we try to modify the query, so from here, it will go to nearer to the positive one. Okay. Okay. So any question? Can you type number 7? Okay. 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 So we continue. So a feedback cycle is composed of two basic steps. Okay. The first one is to determine feedback information that either related or expected to be related to the original query. Okay. So you have this survey, or you could get implicitly from the user action. Okay. And then based on this, we can determine how to transform the query, because our idea is once we get the modified query, it should move your position from the current position nearer to the relevant document. Okay. So our objective is to move this position to the nearer to the relevant document. Okay. So these are the feedback cycle composed of two basic steps. The first one is to capture the feedback. So how do you capture the feedback? Based on user activity, uh, on the click, or where you see the pages. And then from there, you can transform your query to move towards to the um, more positive document. Okay. So in the explicit relevant feedback cycle, we get the feedback directly from the user. Okay. But this is time consuming because you need to interact with the user. Okay. But we do have the web user click history. So from here, we can get all the history of the clicking activity of the user. So this could be used as an implicit relevant feedback. Implicit means indirectly capturing the information about relevant information. Okay, so this is you, and this is the result, and the system will give you a list of ranked document. Okay, then this is you again telling that which one is relevant, and then based on this information we will modify your query. Okay, so from the with this query and with this information here, we will get this. So remember that we have the query here plus the um, relevant document here. So we want to have modified query here. Okay, but then we get the new result here. So with the new modified query, we hope that we get better results. So we will have a loop here. Okay, so this is relevant feedback. But if we are based on what you click, based on your activity, we also can capture. So it will do the same thing also. Okay, so this is in directly getting the feedback from the user. This is based on the history. So these two different things. Relevant feedback based on the user punya respon. Click feedback is based on the user punya activity. Okay. Okay, now we want to look at the implicit relevant feedback, in which we want to look at how we can get the relevant feedback indirectly from the user. Okay. So we have two methods here, but we will look at the local analysis first. We will not cover the global analysis. This one is similar to the local analysis, but this one use the external resources such as Thesaurus. So we will not cover this one. So this is similar to what we have in global analysis, but this one we have all the resources to do the work later on. Okay, so the local analysis derive the feedback information from the top ranked document. So it will be based on the top ranked document that listed in the results that we have. Okay, so this is local, and this is you posting the query, got the result. So based on the result that they have, so we will have some of the um, method. So we call it local analysis. So what we do, we gather all the top results and then we perform clustering. Okay, and from the output of this local analysis, we will feed into here in order to modify your query so that you can get better result here. Okay. And similar to the global, but this one we will use the external resources like this is the Thesaurus, and this is the document collection. So we will do the same thing also. Okay. So let's take a look at this, the first one first. Local analysis. This one is okay. We go back to the explicit relevant feedback. Okay, where were we? Okay, so explicit relevant feedback. So when we look at here, so the explicit relevant feedback, we are looking at the input from the user. So we can capture um, from the user activity, or we can ask them to fill in the survey form. Okay, so a classic relevant feedback cycle normally give you a list of retrieved document, top 20 or top 10. Okay, then the user will examine them and mark those as relevant or not relevant. So this is manually. Okay, and then the main idea consists of we want to select important terms from each document that we have. Okay, and also at the same time we try to enhance the importance of this term in the new query formulation, which means that once we get the document that is relevant, we try to extract the term that we have here, example term 1 and term 2, and then we want to put this term into our query. So our modified query here content of the all query plus the term 1 and term 2. Okay, so this term 1 and term 2 are extracted from this document. So this is the top document. Okay, so these are the main idea that we have. So we select the important terms like we are reading the article, and then we underline what are the importance point in the document. And then once we get that term, then we could use them in order to enhance the query that we have. Okay, So this is the relevant document. Then we extract out the important terms. Okay. And then with these important terms plus the query, we will produce a modified query. Okay. Okay. Any question? Okay. So one of the example for this is that we have this Rockio method. So this is what they wanted to do is based on your query and based on the relevant document that you have, they want to adjust your query direction going to the right direction towards the relevant document. Okay. So how this is being implemented, let's see the formula that we have. Okay. So in the early experiment, they have shown good improvement in precision and small test collection. So this is one of the method that they use in order to uh, get a better modified query. Okay. So relevant feedback present the following characteristic. The first one is it shield the user from detail of query reformulation process. Okay. So the user should not aware of the processing that occur at the back of the engine. Okay, so and at the same time also it break down the whole searching task into sequence of small steps. Okay, so we will show you later on. Okay, so what the user will see in front will be given the query that they have, and then also given the relevant document in which they extract the important terms. They will only see the suggested keyword that they have. So this is what we call modified query. Okay, so sometimes when you type your query, then they will show you the possible expansion of the keyword so that you can get the relevant or more specific document. Okay. So the idea of the Rockio method is that they wanted to have the initial query to move to the relevant document, move towards the relevant document. Okay, but away at the same time also away from the irrelevant document. Okay, so how are you going to do that? So the basic formula will be this is your query, and then you want to move towards the relevant document. So you will say, okay, I will move towards this one. This is no, not query. It's supposed to be document. Okay, so this is your relevant document, but you want to move away from the non-relevant document. So this is an R. Okay. So from here you can get the modified query. So that is the main idea here. You want to move closer to neighborhood of the relevant document in the vector space, but at the same time you want to move away from the neighborhood of the non-relevant document. So this is your basic idea. This is the Rockio method. So remember when you learn how to form the TF-IDF, and when you learn that one document can be represented as a vector of words or a vector of terms in terms of weights. So that is what we will be using here. Okay. So let us define the terminology regarding the processing of a given query. So given this is your relevant document, so you will have this relevant document. Okay, and of course you have the size of your relevant document. Okay, so the NR will be the size of your relevant document, and you also have the non-relevant document. So that is your non-relevant document, and also the size. Okay, so the capital N subscript NR is the size of the non-relevant document. Okay, so we have that one, and the whole thing is the document retrieve. So we could have relevant document, we could have the non-relevant document which is retrieved by your system, and all the retrieved document is part of a larger component which is all the document that we have. Okay, so AR is the set of relevant document among all document in the collection. So the green one is just the one that we retrieve, and then in the retrieve document we have relevant and non-relevant document, but not all the relevant document are being retrieved here. Okay, you got the idea? Okay, so the 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 objective of the search engine is that if possible they want to get all the relevant document, but due to the complexity of the idea, the concept, and also how to get a better one, so we may not be able to retrieve all the document that we have. Okay, so this is the term that we use in order to define the process. Okay, so let's consider that the set of CR is known in advance. So this is what? This is the relevant document. Okay, so let's assume that we know the content of this or the list of document that we have in relevant document. Okay, and then the best query vector for distinguishing the relevant from the non-relevant document is given by this. Okay, so looks familiar, huh? So basically what we wanted to do is any query that you have, you can optimize by having a relevant document minus the non-relevant document. Okay, so we want to go to that direction. We take the relevant document, but we want to move away from the non-relevant document. So basically, we are looking here is for all document that belong to the relevant document, but over here you minus all the document which is not belong to the relevant document. So meaning that this is your relevant document, this is your non-relevant document. Okay? Okay. So these are the term that we have. So this is the size of the relevant document, the size of the whole document that we have. So this is the formula. Okay, how do we apply this one? Um, Let me expand this one more step, because this one is just in the ideal situation. So we have to look at the query that we have. Okay, so let's take a look at the query that we have. Okay, this is in the best scenario. Okay, because we know this one already, but in the real situation, we do not know what is relevant document here. Okay? So to solve this problem, we can formulate an initial query and to incrementally change the initial query vector. Okay? So how do we change that one? Okay, let's suppose this is your relevant document, the dark one. Okay, and this is your non-relevant document. Okay, so the vector that representing the relevant document is this one, and the vector representing non-relevant document will be this one. Okay, so remember that the formula of the optimized one, we have all the uh, relevant document. Let's change that one. You want to have all this dr minus the dn. Okay, so this is in the ideal solution. But if you have the query, before I go to this, so when we try to optimize this, so we take this, let me change the color here. We take this minus the direction of the non-relevant document. So your optimized query will be this position. Okay, but when it comes to the query, when you have the query, okay, so when you have the query here, and this is the direction of the relevant document, this is the direction of the non-relevant document. So what you have to do is you take the query, you move that initial query towards the re- relevant document, and at the same time you minus move away from the direction of the non-relevant document. So this is what we call query, modified query. Okay, so we have the formula here, and let me erase that one. Okay, so they have all the color here. So the green one is your modified query. Okay, so this is the theoretical explanation of Rocchio method. Okay, they know that this is the set of relevant document, and they know that this is the set of irrelevant document. So they take the query and they adjust the weightage of each of the term that they have in the query by adding the weightage of the relevant document and subtracting the weightage of all the non-relevant document. Okay, so if we want to go to the computation of this and how do we apply them, so we will look into this formula and it will be expanded to this. So this is in the first case study too, first case, and this is the second case. So this is the query that we have. This is your relevant document. This is your irrelevant document. So we have some kind of weightage here, the alpha, beta, and gamma. Okay. So based on the research, they recommend that the value for the alpha is 1, the beta is 0.75, and the gamma is 0.15. So this is based on the research. Okay. So what we have is this one, this formula. So we will apply this formula when it comes to the computation or when it comes to the application of Rocchio method in trying to adjust the weightage of the query. Okay. Okay. So you know about TF-IDF. So we for each of the query and for each of the document, they are represented by the weightage. Okay. So in this case, we have the query with this weightage, and of course they have the term. Okay. So the red one denotes the non-relevant document, and then the blue one denotes the relevant document. So what we wanted to do is we want to change the level of importance of the query so that it will move towards the relevant document. Okay, so just imagine that this is your TF idea. This is your TF idea, and we know that this is relevant to the query. No, no, this is the not relevant. Okay, not relevant, and this is the relevant document. Okay? So the process is I get the query and I get the vector for the document that is not relevant and also relevant. We take the average. Okay. So let me erase the here. So our query is this one, and then this is the beta and gamma. Okay. So we are looking at the 0.75, 0.15 here. Okay. How do we get this one? Basically, we take the average lah. We add up all this thing, divide by 3. Okay. So we get that one. Then we get the average here and then the average. So finally we get this one. Oh, this one. So that is the weightage of the new modified query, which means that we are taking this query, and then we change the level of importance to become this. So now this is become more important compared to this. In the previous one, this is less important. Okay, so that's how we look at the um, modified query, and how do we use the Rockio method in order to get the modified query. Okay, so very easy. Okay, so this is some of your exercise later on. Okay, any question? If you still there, can you type number 8? Okay, so how do you find lecturing in online? Can you follow, or you have any question that you want to ask? In online, you can ask any question. People don't have to look at you when you ask your any question, kan? Any question? Semua okay? Okay, less than 100 nih, number 8. Yang lain sudah nih, pergi tamu gadang mungkin. Okay, so let's continue. So now we look at the explicit feedback through click. So we look at that one. Okay. So through the click, we will look at the preference of the click. So there can be a collection of large number of interfering with the user. No, they can be collected in large number without interfering with the user action, which means that the user will not know that we can capture the click activity of the user. Okay, so we capture based on the log. Okay, so the result that presented to the user. So some of them may click several documents that that thought relevant to the query that they have. So we may have something like this. Given a ranking function, okay? So given a ranking function that will take the query and also the document, and this is the k rank result, okay? So meaning that if you have 3, that means that is the third rank result. Let me show you. So this is the first result, second result, third result. Okay. So the check here indicate that the user has clicked the K result. So for example, if we have something like this, so meaning that user only key in result number 3, number 5, and number 10. So what can we assume here? Can we assume that result number 5 is less important compared to result number 3? Or can we assume that result number 10 is more important than result number 3? Okay, the answer is no. We cannot make that assumption, but we do have this assumption that we can apply. We are saying that um, R3 is more important compared to R1 and R2. Okay, so but when we look at here, we cannot make an assumption that the R3 is more important compared to R5 and so on. Okay? But what we can say that we can use this what we call skip above. So meaning that if this is checked, then all the RK which is bigger than this for all this that was not clicked. Okay? So if you look at the RK here, so in our example, this is 3. Okay, so this is 3, and this is R3. Okay, so bigger than what we have here, n. So this is k minus n. What is n? N is 10, kan? Oh, no. Skip above mean, okay, this one is referring to what we have here. Okay, so when we say skip above, so this is more important compared to this. But when we, oh, the other way around, okay, so skip above meaning that this is important compared to the rest of this. The skip previous is this is important compared to the previous one. For example, okay, to illustrate this one. So when we use the skip above strategy, so that means, okay, going back to here again. I think I explained you differently. Okay, so we always look at the previous one, but it depends. The skip above mean you are skipping all the above one, all above these are 3. But the skip previous, you only skip the previous one here. That is easier to explain. Okay. So if this is checked, meaning that skip above means whatever you have seen before, all will be not relevant to the art, no, not relevant to your query. Okay. Skip previous meaning that you the previous document is not relevant. Okay, so this is what we meant by skip above. So the R3 is better than R1 and R2 if 5. So R5 is more important compared to R4, R2, and R1. If 10, so 10 is more important compared to R9, 8, 7, 6, 4, 2, and 1. Okay, so skip above all of them. Skip one, skip previous only one. Okay, the previous. So this is the assumption that we can get from the click. Okay? So skip above strategy produce more preference relation than the previous strategy because the skip above they cover more document. So you can get more preference relation to the other document that we have. Okay? But sometimes when we try to get the result and in the first round we cannot find relevant document, then we change the query, then we get the second one. Okay, so that is what we call chain because we are looking at the first one, this one, the first result, but none of them are relevant. So we skip, then we change, then once we change that one, then we found two of them. Okay, so this is what we call the query chain. The set of query associated with the same task can be identified in live query stream, also known as query change. Okay, so how do we define the relation of this relevant document with respect to all of the other document? We cannot say that this is S2 is more important than S5, but we can make assumption about S2 with regards to other document. Okay, so for this one, we can say that um, we have two sets here. This is the first set. This is the second set. Okay, when we try to use this, what we call top one no click earlier. So top one means the first result. So we say that if there exists a second click, no, a click in the second result, such that that click, then um, this document is more important than R1. Okay. If you look at this one, top to no click, so they are looking at R1 and R2. Okay. So if we have this situation here, this is your second result. Okay. So we are saying that the S1 is more important than R1, R2. No, yeah. The S1 is more important than R1, S2 is more important than R1, and so on. So all of these are with regard to the R1. When we said no top 2, that means no, we are looking at the 2 here. Okay. So the second one, the first result in the second set is more important than the first and the second document in the first result. Okay, so this is what we can um, conclude here. Okay, so any question? Okay, so the main ingredient for this one, for this lecture, is the Rocky method lah. The idea is how do we move the query towards the relevant document and away from the non-relevant document.